Okay, question 19. Diagram shows points P, Q, R, and S so that they lie on circumference of circle center. O, PR is the diameter, and the size of PSQ is 53 degrees. Determine with reasons to assign the size of angle PSQ. So I'll just highlight that one. So I've highlighted in blue the angle I need to find, and I've been given PSQ, so that one's going to be 53. So I'll write that in there. So we do have an angle that has been subtended by the diameter, so that will means it will have to be 90 degrees. So that will be 90, and hopefully we can recognize the bow tie. I will just draw it quickly. If you hopefully can recognize this bow tie. And therefore this angle up here in the corner, QRP, that will also be 53 angles in the same segment. So I'll just write that in also. And then quite simply, for triangle PQR, you've already got the 90 degrees, you've got your 53, P is going to be the remaining. So that will be 37 degrees. 180, take 90, take 53. Because this one is quite straightforward, I won't write down all the steps, but yes, to find angle PQR equals 90, it's subtended by diameter. QSP equals QRP because they're in the same segment, they're both 53 degrees. And the triangle angle sum of triangle QPR sums to 180, therefore 180, take 90, take 53 equals 37 degrees. I believe that's the three things that you would need to get all three marks. Then, when we come down to B, they've got points on the circumference of a circle at center O, tangents to the circle at B and D intersect at E. Determine with justification the size of the angles. So first let's mark down some things that we know. Okay, so I've written down the angle we know, I've highlighted in purple the angle that we need to find out. Hopefully we can see that BCDA is a cyclic quadrilateral, and therefore opposite angles will have to add up to 180 within cyclic quadrilaterals. They need to be supplementary. So it's going to be for angle DAB, it's going to be 180 take 134, which equals 46 degrees. Now hopefully as well we can also remember about a tangent. A tangent to a radius, that will be 90 degrees. So if we make our little radii from the tangents to the center, let's say that lined up perfectly on the center. It does with my stylus, but not really on the screen. So they will form angles of 90 degrees. So I'll put my little 90 degrees box in there. My little 90 degrees box in there. That makes them both of them 90 each, which means they're 180, and for a quadrilateral there needs to be 360, which means the other two are going to be 180 as well. And hopefully also we remember that angle BOD is going to be 46 degrees times 2 because the angle at the center is double that of the circumference. So this one that we had calculated before is 46. Therefore, this one is going to be 46 times 2, which is 92. 46 times 2 equals 92 degrees, and that is angle BOD. And that's for an angle at the center being double that at the circumference. Now, because obviously we've got our 92, our 90 here, our 90 here, and our 92 there, we've got everything we need for the quadrilateral of 360 degrees except our missing angle. So you can actually solve for the shape EDOB by just doing the remaining 180 degrees, taking your 92, and you're going to get 88. So 180, take 92 to get 88 degrees. And that's going to be angle BED, which is the one we needed to find out. So just in summary, all we did is figure out that because we'd already been given 134 and it's a cyclic quadrilateral, angle A is going to be supplementary to that, so it ends up being 180 take 134 to get us our 46. Angle at the center is double at the circumference, that doubles 46 to make 92, and then within a quadrilateral, as long as you've done these lines here to represent that it's 90 degrees where the tangent meets the radius, then that will mean that for your quadrilateral, actually makes it cyclic, but yes, it will mean that you've got 180 degrees less left once for your 360, taken out at EBO and DOB, EBO and EDO, and therefore this purple one here and our 92 will add up to be 180. 180 take 92 is 88. So hopefully that is fairly straightforward.